Okay, so welcome back. And now what we're going to do is we're going to start talking about systems of equations. Okay, so we're going to start with just the idea of what an equation is. How do we solve an equation? Okay, what does it mean to have a solution to the equation? And what does it mean to have an equivalent equation? Okay, all those terms are going to be important to understanding what we're doing here. So the first thing is when we have an equation is, again, two algebraic expressions that are connected with an equal sign. So this is an example of an equation. Okay? A solution to an equation is any value of the variable x. In this case, the variable is x, but any value of x, or the variable of an equation, that makes the equation true, that makes the mathematical statement true. Any value of the variable that makes the mathematical equation true is a solution to the equation. Okay? How do we find the solution to the equation is by changing the given equation into an equivalent equation that has x on one side and all of the other numbers on the other side of the equal sign. So we want x equals whatever ends up on the other side of the equal sign. Okay? Now, so how do we end up with an equivalent equation? Well, by using our operations that we've been using to solve an equation. We want to isolate the x variable on one side. So we're going to use our properties, right? We're going to use the addition property. We're going to use the equality property, right? So whatever we do on one side of the equation, we have to do to the other side. And so what we're going to do is we're going to use the addition property and the multiplication property along with the equality principle to solve and move things from one side of the equal sign to the other side of the equal sign so that we isolate the x. So for example, I could try to find the solution to this by trial and error, right? I could try x equals 1 and see if that works. I could try x equals 2 and see if that works. Okay, and I could try x equals 3 and 4 and 5, right? And if I put 5 in there, boom, it works, right? 5 times 3 is 15, minus 4 is 11. I get 11 equals 11, which is a true statement. Boom, I got it, but that was trial and error. What if I want to solve for this and algebraically? Well, all I would do is, the idea is I want to isolate this x. So I want to have a string of equivalent equations, right, that lead me to my final answer, which is going to have x equals to something. So what am I going to do? Well, let's get rid of this 4. Let's move the 4 over here. How do I do that? Well, if I'm subtracting, then I want to do the opposite of that. So I'm going to add 4 to both sides, right? So 4 plus 4, right? So now I'm going to get an equivalent expression, an equivalent equation. This is going to go to 0. So now I get 3x equals 15. Well, now I know that 3x minus 4 is equal to 11 is equivalent to 3x equals 15. Now what I'm going to do is I'm multiplying by 3 here. So I want to divide both sides by 3. Why? Because 3 divided by 3 is 1. So I get x equals what? 5. And there's my solution. Okay? Have a great day.